I want to talk about calculations and types of calculations. I have a real interest in math and types of calculations that I've encountered, and lately I'm looking at all these megalithic historical stoneworks, and actually they're finding a lot of stone circles in Göbekli Tepe and other places. I guess there was a megalithic civilization or Atlantis, and then it got ruined. So there is all these what I would call analog computer, because I think a lot of these stone circles were used for astronomical calculations, and they were very sophisticated. Uh, they knew about the nutation of the Earth and the position of planets, and the positions of the stones and the angle that they have in relationship to sun or major stars or north star was a form of positioning. And then when Earth moved, then depending on the position of the stone, they could do calculation to figure out the position of the Earth, or the location of a date or other astronomical measurements. Well, the only analog computer that I was familiar with when I was studying engineering was the slide rule. I think you could do a lot of different calculations with the slide rule. The one I remember was my favorite, was the calculating the multiplication of very large numbers. First you take their logarithm using one of the arms of the slide rule, and then add them with the other arm. I guess then you'd convert back to an original number. So it was a pretty handy tool, but all these analog computers, they require the user to be very knowledgeable of what each component or each scale on the analog computer meant, or what was it used for, why was it built. So I'm betting that the people who built Stonehenge, or the people who built these Göbekli Tepe circles, they were also really good technicians, and they could figure out what to do with each stone and the position and the time of the year and the relationship to the stars or to the sun or the moon. Do calculations. So basically it's a form of calculation, but the very first form that was also very sophisticated was the Greeks, that they could use geometry to add numbers, take a square root of numbers, do like sines, cosines, tangent, all kinds of stuff. But that form of calculation gradually evolved through analytical geometry. Kind of like René Descartes and other mathematicians, they combined it with algebra and become a kind of algebraic geometry. It was really interesting. It was also more powerful, and then it evolved into other forms of math, like trigonometric, astronomy, or different forms of analytical geometry, or three-dimensional analytical geometry. So it became ever more sophisticated tool. But after the World War II, people started making digital computers. Actually, it was Alan Turing, the mathematician, that figured out that the basic design of a digital computer is extremely simple. Basically, you write numbers in the form of binary numbers, and multiplication and addition is simply shifting the digits left or right on these numbers, binary numbers, and then you could simply have punch papers or a memory head or a print head that moves along a tape to do the calculation. But you couldn't really do sophisticated calculations using binary math because it would be very tedious. It would be like a lot of steps. But then the computers grew very quickly. They were using punch cards. I remember we used to use punch cards in college, and then it grew to ever more sophisticated. By the time I made it to the university, they were using Unix or VAX. It was a whole bunch of dumb terminals that were hooked to a central Unix or VAX system, and it could do a lot. It could do all kinds of calculations. But in the graduate school, they had come up with MATLAB and MATCAD, and there was another one. I think it was a universal something. It was like MATLAB, and MATLAB also has a lot of people that have made calculations into a certain software that does certain calculation, like a stone circle. That there's some stones that had a special function. Well, now the MATLAB, there are already prepared software that do a certain calculation, say the nutations of the planet Earth, or calculating times over codes of the sun, and so on. And this is not limited to astronomy. It goes into all kinds of fields. All you have to do is look up or download the MATLAB or buy the MATLAB, and then all the other software is like user created, or you can also buy the additional software. So calculations became something that's out there. You just have to look it up. Well, when I was graduating, I was working with the fluid dynamic expert system, that you could give it any kinds of geometry, and it would do flow patterns in 3D and time steps. So it got ever more sophisticated. So now I think MATLAB has a thing called Simulink, something like that, that does simulations. Say, for example, you have aerodynamic flow or fluid flow inside the motor or over the engine, or a shape or a wingspan, and it shows the flow in 3D over a period of time, like whatever time you want, a minute or an hour. Anyhow, I think that there is yet one very sophisticated form of calculation, but this calculation is not something that humans are very familiar with. Well, the Greeks were kind of doing some elementary forms of it by using geometry to multiply and take square roots, but I don't think that the nature does the calculations like digitally. I think nature's way is topological calculations. For example, if you're going to your room or your office or your home and you have a key that's already made, when you put this key in the keyhole and turn it, you're actually doing a calculation, because the shape of the key is it matches the receptor part of the lock. It matches and does the calculation. Same way, when a nutrient or a chemical wants to get inside the cell, the cell has receptors, okay, that are designed for accepting nutrients. But these cells are just like a lock and key. They're geared towards the geometry of the molecule. And so if the right molecule comes in, it'll latch in and just go straight in. Or there is some helper molecules around it to help it down. Just like a lock and a key is a little casing. Anyhow, but it doesn't end there. I think that it can also be said that nature sees by shapes. For example, when genes are being constructed, okay, when the amino acids come in, if they don't have a certain shape, they will not be accepted. But there are millions of these amino acids coming and hit the receptors. The one that's right, it gets in, the other ones are rejected. This can be said to be a form of seeing, a form of, it can also be called calculation. But the thing that makes the topological calculations special is that you can wrap up zillions of steps or algorithmic steps in one calculation. It's like each shape that comes and matches with the receptor, okay, if you wanted to define this shape as a vector, n-dimensional vector, and the receptor as another n-dimensional vector, you probably would have n or 1,000 dimensions on each, okay? And if the computer wanted to match these together, the algorithmic process would be very complex. Whereas nature, when an amino acid or a chemical comes in and the shape is right, it just comes in and hits it and it gets accepted. That's like about 20 million calculations were done, and it was just in a fraction of a second it was done. So nature knows how to do an enormous number of calculations in one shot. Okay, so I think that's how nature does calculations. It doesn't do it like humans. It doesn't go through an algorithm and use algebra. It uses topology and geometry, but it is like a heuristic rules that the human mind uses. For example, when you take the integral of a function, okay, if you wanted to take the integral using an algorithmic method by algebra and computers, you probably have to do about 1 million calculations, because you have to break down the shape into its components in delta x and delta y, and then sum them up using small increments, and define the distances in x and y or z directions in 1,000 steps, and then each step multiplied by another 1,000, so it will be 10 to the 9th steps. So, but when a human does this calculation, want to take this integral of a sine, it just does it by heuristic and knows the answer is a cosine. So that's a many higher order magnitude of calculation than digital computer. But we don't see the problem with the way digital computers do calculations because they're so fast. Okay, in one fraction of a second they can do million calculations. So we don't see how dumb this process is, but because it has been speeded up, it seems, oh, it did it faster than me, but really it wasn't. But then if we could look at nature and how nature does calculations, we see that the natures is many order of magnitude faster by using topology and geometry. In fact, I think when a molecule goes inside a cell, it has a outer lower layer of keys that match, and then when it goes in, there's the side keys that must match, and then so on. So there's like layer upon layer. So it does. If you wanted to define that as a vector space, it would be tremendous number of dimensions that and calculations. But it does it very quickly, and if it's the wrong key, it rejects it. It doesn't have to sit and wait and do the calculation over again. I think it's very smart. And the other thing that's very fascinating with geometric calculation is like how nature constructs proteins, but really it's just a long string of DNA. It comes in and wraps it up and does a little this and that. At the end, it becomes like this lump of molecule or big molecule that has a certain shape, and this shape does something else. So it was a long calculation of manipulating topologically this string, and now it has become this lump or protein, and does so other things. I think nature's calculations are all topological and geometric, and they're extremely fast, and also each step is like about a zillion calculation that could be done with the digital computer. And this field is extremely complex. I think they had a prize for some of this stuff. I forgot. Anyhow, these ideas about geometric calculations can also be thought of as a form of writing, like there's some cultures in the past they used the strings to write numbers. I think that nature writes the information for the genes in this fashion on a long string, but the string has been manipulated to do other things too. The whole thing is very complex. I just think that because these calculations are so complex, that there must be intelligence or a quantum computer, or the universe is a form of intelligence, because these calculations are so involved and so topological that it's just I don't think that this can come through a process of evolution. I don't know, I could be wrong. But hey, thank you very much for being in my YouTube channel, and please subscribe and make sure you leave a comment, okay? Thanks.